Um, and this is going to be participatory. You guys are going to have to talk to me about this. You guys see any difference in this soil? What would be some differences that you see?
Light and dark.
Light and dark. What do you think would cause that? Organic matter. What if I told you that these two soils were taken 20 feet apart? Would you believe me?
Yes.
20 feet apart. This one has been in, this is from the Coshocton Research Farm. It's been in no-till for 52 years of continuous no-till. This one has been, this is a car length away, and it has been tilled for the same amount of time. And so what happens when we till? Well, this looks like a piece of concrete. You can see very little pore space. You can see it's pretty compacted. The organic matter, when we add oxygen to the soil, the copotropic bacteria start eating up all the organic matter, so it dissipates back into the atmosphere. So you can see the difference in organic matter that we have in these two soils. Well, what else happens? So just because it's a black soil doesn't really help us a whole lot. If I were to tell a producer, well, if you no-till for 52 years, your soil will turn black. They'll say, well, so what? You know, what does that do for me? Well, we know what all the benefits of no-till will do for you. We know that it'll store nutrients, it'll recycle nutrients, it adds basically some pore space to the soil. The organisms within the soil create pore spaces, like Frank talked about, the earthworms and things like that. The root channels remain intact, we're not tearing those up. We have fungal growth that grows in this soil, and if we leave it undisturbed, those help recycle nutrients as well. So there's a tremendous amount you know, from a biological standpoint, a tremendous amount of benefit that we see from these two soils. But what else happens? What else happens? You know, what that organic matter does, not only, we can see the organic matter, but what we can't see are the polysaccharides and the glucogen and things like that that are produced by those microorganisms that help bind the soil particles together. That, you know, this has been basically beat to death, and there's none of that left. The biological activity is essentially dead. If we would look under a microscope, we might see some bacteria, and that's about it. So this is called a slake test. You guys, several of you have probably seen it. Raise your hands if you've seen it. Okay, well that's basically what's going to happen when we put these two pieces of soil, these two PEDs, into the water. What's going to happen is water is going to tend to rush into those pore spaces. Now, you know, and that's going to happen under both samples. It's going to happen under the no-till. It's going to happen under the tilled system. Now, what we want, though, is what we want to find out is how much restraint, or how much the polysaccharides and the glucogen hold these soil particles together, so that the soil structure is maintained in the soil. So, need a couple volunteers here. You look good. Come on up here. Another one. Come on up. Got to be a little careful on this so we don't jump around too much. All right, you take the no-till piece since you're on the left, and be very careful with it. What we're going to do, on the count of 3, I just want you to simply place it on the screen. Don't drop it, just kind of place it. And let's do it at the same time. 1, 2, 3. Okay, what do you see immediately happening? What's going on here?
It's falling apart.
It's falling apart. There's nothing to hold those soil particles together. It's simply collapsing. Within seconds, it's collapsing. Now, if there were rainfall on here and the soil structure fell apart like that, what do you think would happen to the soil surface? It would seal off. It doesn't have anything to hold the soil structure together, and it's simply going to fall apart, sealing the soil over and causing the water to run off instead of infiltrate down in the soil. And that's what this next test does. What we have here, these are basically like stainless steel cookie cutters that we had fabricated. There's no bottom in them, except I put a screen on it. So what you do with these, this is an undisturbed sample. You go out into a no-till field, again with the bottom off, and you push it down into the soil, and you take it out, and so you basically have an undisturbed cube brick of that soil. So we have a no-till soil here, and then we have a tilled soil the same way. Okay, and what we're going to do, we know that phosphorus is a big issue up here, right? And we know that there's a lot of surface application of fertilizer, phosphorus fertilizer. And so here's my phosphorus fertilizer. I actually bought it at Kroger's. It does great on cakes. But I'm going to surface apply a little phosphorus fertilizer on here. And then what we have is a couple granulators. These are simply cups that have holes in the bottom, and the same number of holes in both of these. These basically clip in here. So we created a little granulator here. Now what happens is any water that goes through the sample is going to go into the dish down below. If it runs off, it's going to go into this dish. Okay, so we'll see how much in a no-till situation, and no-till up in this part of the state has really taken a lot of blame for this soluble reactive phosphorus issue. With the idea that it causes stratification, and on that surface layer you get a buildup of phosphorus fertilizer. Well, in our demonstration here we put a lot of phosphorus fertilizer right on the soil. So we'll see how a no-till soil compares with a tilled soil. Now these have been in the car, so I'm hoping they work well after being beat to death with the sun at 180 degrees in the car. But I think it's still going to function just fine. So we have 2 cups of water here, and if you guys would, again, what you're going to do is take your cup of water and pour it into the top, and just pour it fast enough at the same rate so that it does, well, it's not going to overtop because the cups are the same size. So just go ahead on the count of 3 and pour your water into the top. 1, 2, 3. Okay, so it's starting to rain. I did this in Salina a couple weeks ago, and they had 4/10 of an inch of rain since June, and their corn looked about 2.5, maybe 2 feet high, and it looked like it was all curled up, looked like pineapples. We did this demonstration, and I asked them if they got an inch of rain tomorrow, where would their rainfall go? Would it go into the soil where they need it for the crops, or would it run off? Okay, and we had a few farmers that were, I could tell that if they got some rain, they would hope that it went into their soil. So what we see happening here is the water's just about through the system. It has dissolved some of the phosphorus that's on the surface, and the tilled soil has done just what this did. It's simply the structure, as soon as water hit it, the structure dissolved, it sealed over the top and caused actually, I would say 100% runoff. In relation to the no-till caused no runoff. Now what's interesting is, again, if you want to look at the bottom of this one, there was nothing that really infiltrated into the tilled soil. It simply sealed off and ran off along with our phosphorus fertilizer.